the first type of model that I would like to start with is called ANOVA model, or analysis of variance model. And this is the regression model that contains regressors that are all exclusively dummy variables or qualitative variables. And let's consider an example. Suppose we've got some data on average salary of public school teachers in 50 states and the District of Columbia for the academic year of 1920. So there are in total 51 states, which can be classified into 3 geographical regions. So the first region is Northeast and North Central, and there are 21 states in all. The second region is South, 17 states in all, and West, this is the last region, and there are 13 states in total. And we want to find out if the average annual salary of public school teachers differs among the 3 geographical regions of the country. So what we would like to see is whether teachers from different regions have different salaries, whether it is more profitable to live in the north than in the south, or vice versa. So on one hand, what we can do is we can apply the statistical tools we already know. So we can just simply calculate the arithmetic mean, the arithmetic average of the salaries of the teachers in 3 regions. However, another problem is that we will not know whether those differences in the numbers, whether they are statistically significant, whether they are statistically different from one another. And thankfully, we've got the tool, the dummy variable tool, which will allow us to answer that question, whether the differences in the salaries are statistically significant. So to answer that question, we need to run the following regression. So we regress y, which is the salary of public school teacher in state I, on beta 1, which is the intercept, beta 2 multiplied by d2, where d2 is finally the dummy variable. And let's see, so this is the dummy variable that takes the value of 1 if the state is in the northeast and north central, and it is equal to 0 otherwise. So let's say if we take the teacher from the north, right, the dummy variable will be equal to 1 for this teacher. However, if we take the teacher from the south, this dummy variable will be equal to 0 for this teacher. Then let's move to the next variable, so beta 3 multiplied by d3. So d3, this is the second dummy variable, and let's see, it takes the value of 1 if the state is in the south and 0 otherwise. So if we take the salary of the teacher from the south, we already know that this variable will be equal to 0. However, this variable will be equal to 1. If we take the teacher from the north, this d2 will be equal to 1. However, now d3 will be equal to 0. And an interesting fact, remember we've had the third geographical region, west. And if you look at this model, you will see that there is no dummy variable for this region. And in a second, I will explain why it is so. So if we take the salary of the teacher from the west, d2 and d3, they both will be equal to 0. So y will be just equal to beta 1. So you already know that actually beta 1, this is the average salary of the teacher in the West. But I will come back to this in a second. And on this slide, you've got the summary of what I've just said. So the mean salary of public school teachers in the Northeast and North Central, this is just the sum of beta 1 and beta 2, right? Because d3 is equal to 0 for the teacher in the North. So what is left is just b1 plus beta 2 multiplied by 1. If we look at the mean salary of public school teachers in the South, we get the following. So this is the sum of beta 1 plus beta 3. Because now in this case, d2, the dummy variable for the North, is equal to 0, and d3 is equal to 1. So this is b1 plus b3. And when it comes to the mean salary of public school teachers in the West, we get the following. So now both dummy variables are equal to 0. And what is left is that y is equal to beta 1 to the intercept.